In today's video, we are diving into the fascinating history of the atom, exploring how various scientists over the centuries have shaped our understanding of what atoms are and how they are structured. The earliest significant idea came from ancient Greece, around 500 years before Christ, when a philosopher named Democritus proposed the concept of atomic theory. He suggested that all matter is composed of tiny, indivisible particles called atoms, which cannot be broken down any further and are separated by empty space. Although this was a powerful idea, it remained largely philosophical for over 2,000 years. It was not until the early 1800s that an English scientist named John Dalton revisited the concept and proposed that atoms were solid, indestructible spheres. He further theorized that different types of these solid spheres made up different elements, marking a significant step toward a scientific model of the atom. However, this model was challenged in the year 1897 by J. Thomson, who, through his experiments, discovered the existence of negatively charged particles within the atom. These particles, which we now know as electrons, suggested that atoms were not solid spheres after all. Based on this new evidence, Thomson proposed what became known as the Plum pudding model, where the atom was seen as a sphere of positive charge with electrons embedded within it, much like raisins in a pudding. This idea stood until the year 1909, when Ernest Rutherford and his students conducted the famous gold foil experiment. They fired positively charged alpha particles at a very thin sheet of gold foil, expecting them to pass straight through if the Plum pudding model was correct. Instead, they observed that while most alpha particles did pass through, some were deflected at angles, and a few even bounced back completely. This unexpected result proved that the positive charge within an atom was not spread out evenly, as Thomson had suggested, but was concentrated in a small central region. Rutherford thus proposed the nuclear model of the atom, which featured a dense nucleus containing all the positive charge, while the electrons existed in a cloud surrounding it. Although much closer to our modern understanding, Rutherford's model had a major flaw. It did not explain why the negatively charged electrons would not be attracted into the positive nucleus, leading to the atom's collapse. This problem was addressed just 4 years later, in 1913, by Niels Bohr. He suggested that electrons orbit the nucleus at specific distances in fixed energy levels or shells, similar to how planets orbit the Sun. This orbital motion explained why electrons do not fall into the nucleus, and it became a cornerstone of modern atomic theory. Over the following years, more evidence supported Bohr's model, and it has remained largely consistent with our current understanding, with only minor refinements. Later experiments by Rutherford revealed that the nucleus's positive charge was made up of smaller units, which we now call protons. Finally, in the year 1932, James Chadwick conducted experiments that confirmed the existence of neutral particles in the nucleus, neutrons, completing the picture of the atomic structure as we understand it today. So, from the philosophical ideas of ancient Greece to the detailed scientific models of the 20th century, the journey of discovering the atom has been long and filled with remarkable breakthroughs. That wraps up everything for this video. We hope you found it helpful, and we'll see you next time.